Hello, I am Antonio Nate, and as a BSCSE student, the mathematical concepts learned in class, such as isometries, freeze patterns, and cryptography, support programming skills through functions, loops, and user inputs. Mathematics also aids in decision making, especially when choosing between simple or complex projects. Freeze patterns stood out most as they involve motifs repeating infinitely in two directions and can be creatively implemented through programming. While initially focused on memorization, recognizing solution patterns made concepts in this course easily to grasp for me. Concepts like translation, rotation, reflection, and glide reflection were easy for me to learn during this course, while fractals and linear programming posed a challenge to me when learning them. Game design sparked personal interest in me for self-paced learning due to the similarities the concept has to multiple topics in this course. Observing how developers use patterns and decision-making revealed parallels to mathematical concepts. In addition, players analyze boss attack patterns and level patterns, which resemble reset and freeze patterns, as well as understanding the payoffs of each decision that the players make in order to achieve desired outcomes. The three words I can say about this course are interesting, diverse, and appreciating.
We spend countless hours using our phones to access data from all around the globe, constantly sending, receiving, and processing information. In the modern world, data is everything. But during transmission, data can be interfered with and potentially lose the original message being sent. Luckily, math provides a solution. Through coding theory, we use mathematical techniques to detect whether the data we receive has been changed or damaged, and then rebuild it so that the original message is preserved. But accuracy alone isn't enough. We also need our data to be safe and secure, especially when it contains personal or confidential information. This is where cryptography comes in. Cryptography allows us to encrypt data so that even if someone intercepts it, they cannot access the actual message. As CCS students, it is our job to understand how these systems work and to improve upon them, making data transmission more reliable and secure. The concept that struck me the most is that math isn't just about numbers, it's also an art. You can see it in patterns like the Fibonacci sequence in flowers and shells, and in art through symmetry, shapes, and repeating designs. It's really cool to realize that math isn't only something in textbooks. It's everywhere in the world around us. I never really thought about how much math is involved in daily life. This course showed me that even in simple tasks, we use math, and in discovering that has been really cool. As young adults, we're starting to be more independent, and investing has really caught my interest. Not only could it provide passive income while I'm studying, but it also gives me a chance to learn how to handle my own money and make smart financial choices. If I were to describe my experience in this course, it would be tough, interesting, and fun. And I'm Bien Leonidas M. Balagtas from S11C.
As the term comes to an end, my appreciation has matured for what I have experienced and learned so far in my time in DLSU, especially when it comes to mathematics in the modern world. I would describe my overall experience in the course as enlightening, engaging, and of course, helpful. The topics discussed in the course were both familiar and new, blending a fair balance between easy and difficult. The course reintroduced math to me in a new and more extensive setting other than the theoretical or in terms of my future career, which is daily life. This is what impressed me the most about the course, how it introduces mathematics to us as a tool that we could fundamentally use in any scenario. Take for example my field, which is computer science. Topics like the compound and connective statements taught in mathematics as a language are utilized in my field's foundation of logic solving, as seen in the conditional and loop statements found within our codes. This topic can also be applied to other fields, such as business when it comes to stocks, or just other scenarios in general, like when predicting the weather or when you're trying to convey your opinion to another person through the rules of inference, such as if there is a pattern through previous instances, then the next will follow. The topic of isometries also interested me a lot. How it explained art itself as well as nature through numbers, something I never thought would have been possible since art itself to me is something more bound to emotion than technicality. Out of the topics discussed though, game theory is what struck me the most. How it simply and properly conveys the benefits and disadvantages when it comes to decision making. Say if someone's getting disadvantage through a decision, then the number goes down in the payoff table. But if someone is getting benefited, then the number increases. If everyone is disadvantaged, then the number is negative. It really interested me so much that I went deeper into it since I always thought that game theory was just about statistics and probability. This goes to show the ways mathematics helps us when we learn it practically and apply it within our real lives.
My name is Mateo Covar, and I just finished GEMATHMW. As a computer studies student, I think there are many things we can implement from this course into our journey to becoming a practitioner of computer studies. First, mathematics and efficiency. In coding, there are many ways to code one same thing, such as in math, there are many solutions you can come up with for the same answer. Next, math and decision making. There are just some things you can't predict 100% in coding, but with decision sciences, we can come up with the best possible output for those things we can't really predict. Next, communication technologies. While you're surfing the web, it isn't 100% safe, but by software engineers learning how topics in communication technology work, they can come up with things such as better encryption and decryption. That way we can surf the web at least a lot more safer. One topic that stood out to me was game theory under decision sciences, since it's interesting to see how the way we think and the way we make our decisions is placed in such a way where math is involved. I think these topics were really helpful, and we can see them a lot in our everyday lives. We can see them pop out a lot. The topics weren't hard to learn, but at the same time, they weren't easy. Still, it was really interesting to learn these topics. Now, one thing that I want to learn more is I want to expound more about my knowledge on game theory. Like I said earlier, it's interesting to see how the way we come up with our decisions is placed and how math is involved in it. 3 words I would use to describe this course is, relevant, analytical, and useful. Thank you.
Hi, my name is Nathan. As we move around with today's technology, with everything around us, math in the modern world has definitely taught me some things. One of those things... Alright, I'm hungry. Let's make something. Yo. Oh, who are you? It's just your brain. Relax, relax. Why are you just like that? I do look like this. It's a thing. Yeah, that's fair.
Well, let's answer a few questions then, shall we? Sure. How do you think you could apply, all the stuff that you learned in the class? Like what? All the concepts, finances, language, or decision making. Give examples. All right. Math and finances, that's a really good one because it helps you consider the different spending things that you do. Money and computation on our own finances, or different ways to spend or earn it, is a very interesting topic where it applies to yourself as a person. Everyone spends, right? All right. How about you as a computer science student? Oh, easy. application of efficiency or language, how it's the most efficient or what's the simplest way to get to solve that problem, or how language interprets in code, right? You know, with C having to interpret for or do while loops, or how do you get an if condition to work. Good. I mean, did the topic stick out to you in any way? Oh, definitely. Math and finances.
The discussion about how you can spend your money both in short and long term with the use of simple or compounding interest, or even the benefit of compounding your own money or depositing it with higher interest rates.
Interested me. How do you see each view and learning concepts were? Each concept, it was interesting. It was discussed in a very sensible and practical application. We had applications towards different problems and solutions that applied to each person, and the best bit was, it was familiar, yet challenging. Did any concept intrigue you, or did it make you curious? Definitely. The concept that interested me the most was the mathematics in art. The symmetry dissonance of the form and shape, where art may feel repetitive to the eye or its patterns may seem free-flown, can be formed into beauty of formula and arithmetic. It's strange, yet it combines itself. Good. Now name 3 words that describe your experience in this course. You were getting me to answer the questions, weren't you? That's right.
I think you can answer the last question. I guess I can now.